Hello, hello. I hope you are having a great day. And yeah, great day, and you're working on your homework diligently. Let's get to it. Lesson 6.7, staking it. Whatever that means. Okay. Ready, set, go. Ready. Given the equation of a circle centered at 0, 0, find 1 point. 1 point, so that means X and Y, right? X and Y in each quadrant that lies on this given circle. So it has to lie on this circle. Okay, so again, let's kind of just talk about my standard form. X minus h squared plus y minus k squared is equal to r squared, where h and k are my center. Okay, so we know that it's centered at 0, 0. And find 1 point in each quadrant that lies on the circle. So if it lies on the circle, it must what? It must satisfy the equation, right? Okay, so what do I mean by that? Let's draw it out a bit and hope that it's I hope that it's okay. Let's just kind of pretend this is a circle. Let's call my radius 5, right? So what does that mean? So here my radius is 5. How do we know? Because r squared is 25, then r is 5, right? Okay. So then this right here is 5, comma 0. This right here is 0, negative 5. Here we have negative 5, 0. And here we have 0, 5. Okay? So those are our maximum points, right? This is the furthest the circle can ever go out because the radius is only 5. Okay? So if I want to find a point that lies on the circle, that means it has to be on this, right? I don't care about it being inside. I want it to be lying on the circle itself, okay? So, quadrant one. If I'm being honest, your answers will vary. Your answers will not look the same as mine, okay? So, I'm gonna go off and kind of just think about a number between 0 and 5 for x, right? We'll call it 3. So if I want x to be 3, that means that this is 3 squared plus y squared is 25. And why don't I just put a magic number? Why don't I just do like 7 for y? Because it won't work out. It won't equal 25, right? So then I get that y squared here is 25 minus 9, which is equal to 16. So then y squared is equal to plus and minus 4. Now in quadrant 1, my y is positive. So my point here should be 3, positive 4. So we'll put it at 3, 4. Let's just say that it's there. And I'll use a different point. Okay, now quadrant 2. You should know that I can do this. And it's going to be on the same circle too, except what's going to change? My x coordinate would become what? Negative, right? So this should become negative 3, comma 4. And I can do this. I can repeat this. I can go down here. And let's call this a point here. What point is that? Negative 3, comma what? Negative 4. Okay? And then last but not least, this point right here can be what? 3, comma negative 4. Okay? Very, very important. Okay? I didn't have to do that. I could have chosen a completely different value. And for the fun of it, let's do it. So in quadrant 3, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. In quadrant 3, let's say my x value would have been, I don't know, let's say 4. So I would have gotten negative 4, right? So negative 4 squared plus y squared equals 25. So then y squared is equal to 25 minus 16, which is equal to 9. So then y is equal to plus and minus 3. So my other point could have been that x was -4 and y was what? -3, right? So these two are totally acceptable, right? So that's my whole point. That your answers might look different than mine, but this does not mean that you are wrong. What, how will you be wrong? You will be wrong if it does not solve accordingly, right? So for example, if you had told me that your x value was -2, let's say -2, and then you told me that your y value was 10. Let's just say that. So -2 squared is 4, plus 10 squared is 100. That's 104. That does not equal 25. So therefore, that point does not lie on this circle, okay? That's kind of like the biggest takeaway from this, okay? Okay, so let's jump into number 2, okay? I'm gonna draw a little circle, little circle something. Oh my goodness, what is happening? I swear, it hates me. It just hates me. Okay, drawing a circle. Oh my goodness. What? Okay, and I'm gonna make this smaller. Okay, because it has a radius of what? What's my radius here? My radius is 2. Good. So again, let's just kind of label the maximums. Well, not the maximums, but let's label the intercepts. Let's call them that. This is a 2, 0, 0, comma 2. Here we are at -2, comma 0. And then here we are at 0, comma -2. Okay? Again, in quadrant 1, you can pick any point you want for x that's between 0 and what? 0 and 2, right? Not including 0 or 2, right? Because, yes, okay. Let's talk about if I said that x was equal to 1. Let's just call that. So I'm going to get that this is 1 squared plus y squared is equal to 4. Y squared is equal to 3. And then y is equal to plus and minus square root 3. So my first point that I want can be 1 comma square root of 3. That's my first point, okay? Now quadrant 2, it's going to be -1 square root of 3, right? Again, this all falls from the fact that it can be a little square. Well, not a square, but add 1, so 1 and a -3, we'll call that there. Then I can be here, I can be here, I can be here, right? So then quadrant 3, at quadrant 3, this point will be -1, negative square root of 3. And in quadrant 4, I'm at +1, negative square root of 3. And all these 4 points satisfy this equation. Okay, they satisfy the equation. That's what you need to be concerned about. Okay, let's test it out. If I have 1 squared plus negative square root of 3 squared equals, so I have 1 plus negative square root 3 times negative square root 3 will be 3. So 4 equals 4 is a true statement. So therefore, those points work out for me, right? Okay, for 3, I can draw another circle, another coordinate, okay, with a radius of 6. Make it bigger, right? So again, it doesn't matter what points you pick, right? As long as it's between 0 and, well, 6 comma 0 here, right? And now here we are at 0 comma 6, so we're at -6 comma 0, and we are at 0 -6 here. Okay, quadrant 1, I can pick any point that's between 0 and 6. I'm gonna call the shots, and I'm gonna say that x here, we'll just call it 5. We'll call x 5 here. So I want to have 5 squared plus y squared is equal to 36, right? So then solving for y squared is 36 minus 25. So y squared is equal to 36 minus 25 is 11. That didn't work out as nice as I thought. And then y was equal to plus and minus square root of 11, right? In quadrant 1, though, I have this is 5, and I have to have positive square root 11. Okay, so let's just call that, that's going to be add 5, let's call it here. Okay, and again, same concept, and now I'm over here. This would be negative 5, positive square root 11. For quadrant 3, I'm now at negative 5, negative square root 11. And then quadrant 4, I'm at positive 5, negative square root 11. Okay, again, your answers might look different than mine. Okay, now for 4, what are we going off for? So 4 is a little bit different, right? Why? Let's work it out on the remix. Okay, so I have a unit circle. Does that ring a bell? Unit circle? Maybe? No? Well, maybe it will. Um, this is a unit circle because it has a radius of what? Radius of 1. Okay? So I want to pick a value between 0 and 1, and I'm going to pick 1/2. So my 1/2 is x. So then this will be 1/2 squared plus y squared equals 1. So then I'm left with y squared is equal to 1 minus 1/4, which is 3/4. So then y squared is equal to 3/4. Get that y is equal to plus and minus square root of 3/4, which is equal to square root of 3 over 2. Okay, plus and minus, plus and minus. Now at quadrant 1, I want to use 1/2 square root of 3 over 2. At quadrant 2, I'm going to use negative 1/2 square root of 3 over 2. At quadrant 3, I'm going to use negative 1/2 negative square root of 3 over 2. At quadrant 4, I'm going to use positive 1/2 negative square root of 3 over 2. Okay, so I'm moving a little bit faster now because we should be more familiar with how to do these. And then last but not least, again, my radius here is equal to 3. So any value between 0 and 3 would work for x. So let's say that x is 2 here. So now I'm left with 2 squared plus y squared equals 9. So then y squared is equal to 5. So then y is equal to plus and minus square root of 5. So for quadrant 1, I'm at 2, comma, square root of 5. For quadrant 2, I'm at negative 2, square root of 5, negative 2, negative square root of 5, and then I'm at 2, negative square root of 5. Okay? How do I know if this works? Well, you double check your answer. So add negative 2 squared plus negative square root of 5 squared. Okay? Negative 2 times negative 2 is 4. 4 plus negative square root of 5 times negative square root of 5. It's going to make it go and be 5 equals 9. Equals 9. It's a true statement. So therefore, my answer here, these 4 points are correct. Okay? Okay. That was a lot of work. Now let's kind of jump into the set section. So each circle has been divided into equal sectors. Okay, find the measure of the central angle formed by 2 consecutive spokes. Write the measure of the angle in degrees and in radians. Okay. Okay. So I think some important key points is that one circle, one entire circle. Oh my goodness. One circle. One circle is 360 degrees is equal to 2 pi, right? One entire revolution. One entire revolution. Okay? So here there's 1, 2, 3, 4, 5. So there's 5 sections here. So this angle is 360 dividing it by 5, which is equal to 72 degrees. Okay? Now radiant is 2 pi equals to 5, which is equal to, I'm not sure if they wanted for us to do it, but let's do it anyways. 2 pi divided by 5. So it's 1.26. So this is 1.26 radians. Okay. Now this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9. So then 360 divided by 9 is 40 degrees, right? And then this is 2 pi over 9, which is equal, let's go here, 2 pi over 9, which is 0.698. Let's just call that 0.7, 0.7 radians. Okay, I hope that kind of makes some sense, right? So each of these is 40 degrees, 40 degrees, 40 degrees, because in total, they have to add up to 90 degrees, right? Sorry, 360 degrees. So these are all equivalent, okay? So they're all equivalent, so they must each be the exact same angle, okay? Okay, find the length of the arc. So we're talking about arc length now. So arc length is a little bit straightforward. So my arc length arc, is equal to r times theta, where theta has to be in radians. Okay, that is like the biggest takeaway from this. I would be really familiar with this, and I would understand that the central angle theta must be in radians. Okay, I cannot stress that enough. Theta has to be in radians. Okay, you cannot be multiplying it by a degree. Okay, you cannot multiply it by a degree. Okay, okay. So the length of the arc, that's usually known as S. So we'll say that S here is equal to 33 times 0.286. Okay, and it becomes just a matter of plugging in your numbers. So this is pretty straightforward. So 33 times 0.286 is equal to 9.438. 9.438. It is important to put units. What are the units here for arc length? And again, sorry, maybe I should have drawn up a little bit of a picture. So the arc length formed, just to recap from class, an arc length, let's just say that this is a pizza. This is a pizza, right? I'm cutting this pizza up. This is theta in radians. And the arc length is like the size of the crust. So this crust right here, the crust, just the crust, the circumference almost, right? So then here, this is should be centimeters. Okay, now I have that S is equal to 14 feet times 2.629. Okay, so again, 14 times 2.269, which is equal to, sorry, it's 14 times 2.629. 2.629. So 36.806. So 36.806. So what is happening? Oh, this is frozen. So 36.806 feet. Feet. This is feet. So we use feet. Okay. Same thing here. This is going to be 20 times pi over 4 radians. Do not be afraid that it's a fraction, right? Your calculator is smart enough to do that. So we'll get 20 times pi over 4 radians. Enter. 15.0708. This is 15.708 inches. Okay? Okay, let's go. So we have S here is equal to 4 times 60 degrees. So am I going to put 60 degrees there and multiply it out and do it? No, that is not right. Okay? I need to convert. So convert 60 degrees to radians. Okay? How am I going to do that? So two different ways of doing this. If you do not memorize it off, well, the unit circle. Okay, so we can convert it. So I get that pi over 180 degrees is equal to radians, what I'm looking for. 60 degrees goes here, right? I multiply this across. 60 pi is equal to 180 rads. And then I divide this by 180, right? 180 degrees, 60 degrees. So now I'm left with just pi over 3 is equal to my radian degree. So S here, let's make this a little bit smaller, bring it to the top. So now S is equal to 4 times pi over 3, which is equal to 4 pi over 3 meters. And let's not just leave it like that. So let's multiply it out. So 4 pi over 3 is equal to 4.188. 1.1 4.189 189. So 4.189 meters because I'm using 3 decimals. Okay, so this was a little bit of a extra step here that we needed to convert this to radians. Okay, so this is what it is in radians, and then you plug it back in. Okay, cool. Find the measure of data in radians. So again, this is arc length. Arc length here is S. This is 12. This is 12. So now I'm asking you to solve for data. So S is equal to R times data in radians, right? So again, if this is 12, my radius is 10 times data. How do I solve for data? So now solve for data by dividing this by 10. Okay, so I'm going to write it again. 10 times data, divide this by 10. Now I'm left with 6 over 5 is equal to data. So I can leave my answer like that. Or convert it. So this is 1.2 radians equals data. Okay. 13, same concept. 6 here is equal to my radius of 13 times data. Now I divide both sides by 13. What I do to one side, I do to the other. Good. So 6 over 13 equals data, and that's in radians. So a little bit over 0.5. So 6 divided by 13. Well, under. So 0.46, 0.462. So this is a 0.462 radians. Okay. Good, good. What about 14? Same concept, right? So I have 75 as my arc length. That's equal to my radius of 25 times data. So then I divide both sides by 25 by 25. 3 is equal to my data. So then 3 radians. Okay. This one, do not be scared, right? It doesn't really make any big of a difference. So 63 is S equals to my radius 9 times theta. Now I go ahead and divide this, right? Divide this by 9, divided by 9. I get that 7 is equal to theta. So 7 radians. Okay, perfect. Okay, convert from degrees to radians. Leave pi in your answers. So this goes back to what I mentioned earlier, what I did a little bit of here. We're gonna go ahead and convert all of these from degrees to radians. So there's different ways of doing this. There's two ways, which is exactly the exact same way, but I'm gonna explain them just differently. So one way is to do the ratio. So pi over 180 degrees is equal to a radian over degree, and then cross multiply. So if I'm going from degrees to radians, let's go ahead and multiply it out. So I'm going to get pi times degrees is equal to 180 times radians. And if I'm going from degrees to radians, that means that radians is always going to be equal to pi over 180 times my degree. Okay, so if I'm being honest, you can just simply use this here. So if I'm going from 90 degrees, this would be equivalent to pi over 180 times 90, right? So this is equal to just 90 pi over 180, which is equal to pi over 2. Okay. For the next one, it's going to be equal to pi over 180 times 210 degrees here. So again, you get 210 over 180 degrees pi. Now you simplify that further, right? So think about what numbers can I divide the top and the bottom by to simplify it further. Think about 30, right? I think to me it comes pretty straightforward. To you, it might not, which is totally fine. But I think that realizing that this can be thought about 21 over 18, and then that's going to be by 3, right? So this should be 7 over 6, 7 pi over 6. Okay, for 72 here, we're left with pi over 180 times 72 degrees is equal to 72 over 180 pi. Actually, these shouldn't have degree. This shouldn't really have a degree anymore. Yeah, and then we can simplify this further. So this one, I mean, honestly, off the top of my head, doesn't really come to me. Well, we can divide this by 60. Let's divide by, no, not by 60. Let's divide this by 6, right? So if I divide the top and the top and the bottom by 6, right? This is gonna get me 12 over 30 pi, but I can still simplify this even more, right? So what if I think about dividing this top and the bottom by 6 now? So then I'm gonna left with 2 pi over 5, and that's best, right? Okay, now I'm left with pi over 288 times, sorry, not 288, oh my goodness, 180 over 288 degrees. Well, 2 times 288 is equal to 288 over 180 pi. We should simplify our answers further, okay? And I think that taking it slow, let's take this one slow so you can steal my work. So if I divide the top and the bottom by 2, this is 90, and the top would become 144, okay? 144. Now, I can divide that again by 90. Sorry, by 2. So I'm left with 45, and the top would become 72. Okay. And now can I divide that by 2 again? No, I can't divide that by 2. It won't work out. But I can divide the top and the bottom by 9, right? So this becomes 8 pi over 5. Okay. Last but not least, pi over 180, 270 is equal to 270 over 180 pi. This one is a lot more straightforward. I can divide the top and the bottom by 90, right? This goes away, and I can divide them by 9 technically. So I'm left with 3 over 2 pi. So 3 pi over 2. Okay, cool. Go. Okay, so label each point on the circle what measures of the angle of rotation in standard position. Angle measures should be in radians. Okay, so again, a full rotation around the circle is 2 pi radians. So anywhere, the entire thing has to be 2 pi radians. So let's see how many times this has been cut. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means that each of these should be equal to 2 pi over 12, which is equal to pi over 6. That means that the first one should be pi over 6. And what does that mean for the rest of them? That I add how much to each of them? I add pi over 6, right? I hope that that's like a big connection. So that means that each of them have to be pi over 6. So each must be pi over 6. But if I'm at pi over 6 already, now I'm adding pi over 6. This is 2 pi over 6, which is pi over what? Pi over 3, right? So I'm going to erase this and just keep pi over 3 here. Okay? Now the next one, same thing. This is 1 pi over 6. I'll make this as 2 pi over 6. The next one will be what? 3 pi over 6, which is equal to just pi over 2. So 1 pi over 6, 2 pi over 6, 3 pi over 6. The next one will be 4 pi over 6, which is equal to 2 pi over 3. And then it's going to be 1 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and then 5 pi over 6, and then 6 pi over 6, which is just pi, and then 7 pi over 6, and then 8 pi over 6, which is 4 pi over 3, and then 9 pi over 6, which is 3 pi over 2, and then 10 pi over 6, which is 5 pi over 3, and then 11 pi over 6, and then 12 pi over 6, which is equal to 2 pi. Okay, so we did it. We did it. Hooray. So we start out at pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, oops, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. Okay, let's think about the next one. So, same concept. This is 1, 2 cuts, 3, 4, 5, 6. So then, again, this is 2 pi over 6, which is equal to pi over 3. So is each is pi over 3. So then the first one here is pi over 3. Pi over 3, right? Okay. Now B. if this was pi over 3, this is also pi over 3. So what is b here? Pi over 3 plus pi over 3. Very nice. Which is 2 pi over 3, right? So then this is what b is. B is 2 pi over 3. What will C be? I keep adding what? Pi over 3 to each of them. Pi over 3, pi over 3, pi over 3. So then this finally becomes 3 pi over 3, which is equal to just pi. Okay? And then you're left with 4 pi over 3, and then 5 pi over 3, and then 6 pi over 3, which is just 2 pi. Okay? Pi over 3, 2 pi over 3, pi, 4 pi over 3. I'll put these closer. Over 3, and then 2 pi. Beautiful. Okay? 23. Let's see what is going on here. So that's how many cuts do we have? So we have we'll call A. So this is funny. This is interesting. We'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So then again, 2 pi over 16 is equal to pi over 8. That means that each of them, each is pi over 8. That's what I want you to understand. That each of these little cuts here is pi over 8. So at B, so technically at B is the first one. So at B, we are going to call this pi over 8. And the next one is 2 pi over 8, which is just equal to pi over 4. So 1 pi over 8, 2 pi over 8, and then 3 pi over 8. I'm going to actually erase these because I think they're going to confuse more than they're going to help us. And then you get 4 pi over 8 here, which is equal to pi over 2. Okay? And then we left with 5 pi over 8, 6 pi over 8, which simplifies to 3 pi over 4, and then 7 pi over 8, and this is just going to be pi, and this is 9 pi over 8. So just to be clear, this is 8 pi over 8, right? And then we get 10 pi over 8, which is 5 pi over 4, and then we get 11 pi over 8, then 12 pi over 8, which is 3 pi over 2, okay? Then we get 13 pi over 8, then 14 pi over 8, which is equivalent to 7 pi over 4, and we're left 15 pi over 8, and then 16 pi over 8, which is just equal to 2 pi, and we did it, okay? So 2 pi here, pi over 8, pi over 4, 3 pi over 8, pi over 2, 5 pi over 8, and so on. This is getting more and more what? They're splitting it up into more and more pieces, right? But at the end of the day, it still equals to what? 2 pi. Very nice. Okay, this is 1, 2, 3, 4. This is last one. Okay, so again, they cut it into 4 pieces. So then 2 pi over 4 is equal to pi over 2. That means that each of these is pi over 2. So then at B, I am at pi over 2. At C, I am at 2 pi over 2, which is just pi. At D, I am at 3 pi over 2. And then at A, I am back at 2 pi. So again, this is 4 pi over 2, which is just 2 pi. So pi over 2 here, pi, 3 pi over 2, and 2 pi. Now, what did you notice, if anything? So I hope you noticed that at the top point right here, it's always equal to pi over 2, pi over 2, and pi over 2. Here, it's always equal to pi, 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 and pi. At the very bottom, it's 3 pi over 2 always, 3 pi over 2, 3 pi over 2, and that at the very back, when you made your way around, it's just 2 pi. So 2 pi, 2 pi, 2 pi, and 2 pi, okay? I hope that was all very insightful. I hope you learned a little something, and I hope you are having a great day, okay?